show that integral 0 to 1 x square dividing by square root of 1 minus x power 4 into dx multiplied with integration 0 to 1 dx dividing by square root of 1 plus x power 4 into dx equal to pi by 4 times root 2. So here we have the denominator 1 dividing by square root of 1 minus x power 4, and here 1 plus x power 4 is there. This one we must write it as 1 minus sine square. So here x power 4 is nothing but sine square theta, and x can be written as sine square into 1 by 4. This power 4, bring it to right hand side, it becomes 1 by 4 theta. We can write it as sine power 1 by 2 theta. We differentiate this one dx. So by using the power, we can write it as first sine 1 by 2 into sine power 1 by 2 minus 1 is minus 1 by 2 theta. So we have differentiated only the power. Now differentiation of sin theta is cos theta into d theta. So here x is 0. Here if we substitute x is 0, theta is 0, x is 1, theta is, sin theta is 1, x is 0, theta is 0, x is 1, that is sin theta is 1, sin theta is 1, theta is pi by 2, sin 90 degree is 1. Similarly, for second part here, we consider here 1 plus is the x power 4 equal to, we must take tan square theta or cot square theta. So similarly, we can write x as tan power 1 by 2 theta. Now we differentiate this one dx. So dx we can write it as 1 by 2 tan power minus 1 by 2 theta. Tan theta is secant square theta into d theta. X is 0. Tan theta becomes 0 when theta is 0. So here x is 0, theta is 0. X is 1. Tan inverse of 1. When will you get tan inverse of 1? When it is pi by 4. Tan 45 degrees pi by 4. So here the question we modify and we write it as integral 0 to pi by 2. X square is there. X is sin power 1 by 2 theta. We square this one dividing by 1 minus x power 4 is sin square theta, and dx is nothing but 1 by 2 sin power minus 1 by 2 theta into cos theta d theta. This is I1. Now we simplify this one, integration 0 to pi by 2. 2 get cancelled, we get sin theta, and 1 by 2 we write it outside, and this 1 minus sin square theta is square root of cos square theta. Square root of cos square theta can be written as cos theta. Here sin power minus 1 by 2 is there into cos theta into d theta. So cos theta get cancelled. If we simplify further, this one we can write it as 1 by 2 integration 0 to pi by 2. This one here sin power 1 is there. If we add this one, we can write it as sin power 1 by 2 theta into d theta. Here cos is not there. If we want to modify, we can write it as cos power 0 theta into d theta. So here this one is nothing but 1 by 2 into this 1 by 2 is there into 1 by 2 of beta of m comma n. So here m 2m minus 1, this is the form of 2m minus 1 equal to 1 by 2. 2m is 1 by 2 plus 1, 3 by 2. M is 3 by 4 and 0 is there. 2n minus 1 is 0, n is 1 by 2. So here we get this as 1 by 4 beta of 3 by 4 comma 1 by 2. If we substitute, we get gamma 1 by 2 into gamma 3 by 4. If we add this one, we can write it as gamma 5 by 4. So let it be, this is equation number 1. The second part of the question. What is the second part of the question? Dx by square root of 1 plus x power 4 is there. The second part, we write it as second part, integration 0 to 1 dx by square root of 1 plus x power 4. So here we have simplified this one and we have written the limits. Theta is 0, theta is pi by 4 and dx is nothing but 1 by 2 into tan power minus 1 by 2 theta into secant square theta. So we substitute here 1 by 2 into tan power minus 1 by 2 theta into secant square theta. This is dx. Limit is 0 to pi by 4 dividing by square root of 1 plus x power 4 is tan square theta. So here we can write it this as 1 by 2 integral 0 to pi by 4. 1 by this tan inverse can be written as tan power sin power minus 1 by 2 theta dividing by cos power minus 1 by 2 theta, and here into secant square theta is there dividing by here square root of secant square theta into d theta. So here if we simplify this one, we can write it as this one is nothing but sin power minus 1 by 2 theta. Here we can write it this as secant theta. If we cancel one, we write one more line. Secant square theta dividing by secant theta into d theta. We can cancel one secant theta and secant theta can be written as secant theta can be written as 1 by cos. So 1 by cos theta into d theta. So limit is 0 to pi by 4. So here power 1 is there. If we simplify this one, we can write it as 0 to pi by 4. This is 1 by sin power 1 by 2 theta, and this is nothing but cos power 1 by 2 theta into d theta. So here we modify this one. One by 2 integration 0 to pi by 4 d theta by sin theta into cos theta. Sin theta into cos theta is sin 2 theta dividing by 2. Here power 1 by 2 is there, so we can write it as sin 2 theta dividing by 2 square root. So here we must consider t equal to 2 theta. dt is 2 times d theta. Why? Because here sin 2 theta is there, and here if we substitute 0, theta is 0, theta is pi by 4, t is pi by 2. So the limit we get 1 by 2 integration 0 to pi by 2 d theta is dt by 2, and here square root of sine t dividing by root 2 is there. Here we can simplify. We can write it as 1 by 2 root 2, and this one bring it to numerator. We can write it as sine power minus 1 by 2 t. There is no cos, so cos power 0 t into dt. Limit is 0 to pi by 2. So this also the form of beta gamma function. We can write this as 1 by 2 root 2 into 1 by 2 beta of m. Here 2m minus 1. 2m minus 1 is minus 1 by 2. M is 1 by 4. And 2n minus 1 is 0. N is 1 by 2. We simplify this one. We write it as gamma 1 by 4 into gamma 1 by 2. If we add, we get gamma 3 by 4. This is equation number 2. Now we multiply 1 and 2. 1 into 2. So what is 1? 1 is 1 by 4 into gamma 1 by 2 into gamma 3 by 4 by gamma 5 by 4. 1 by 4 gamma 1 by 2 gamma 3 by 4 dividing by gamma 5 by 4, and here we have 1 by 4 root 2 into gamma 1 by 4 into gamma 1 by 2 dividing by gamma 3 by 4. So we can cancel this one, and gamma 1 by 16 root 2. This one we can write it as 1 by 4 into gamma 1 by 4. It is nothing but 1 by 4 plus 1. It is nothing but 1 by 4 into gamma 1 by 4. Using the formula gamma n plus 1 equal to n gamma n. And the numerator 1 by 4, gamma 1 by 4 is that we get cancel this one. We can cancel 1 4, and gamma 1 by 2 is square root of pi square. We get pi by 4 root 2. Hence, so here we can see it is nothing but pi by 4 root 2. Hence it is proved.